So in chapter 2, we looked at what happens when you take the square root of f of x, and there were special things like 0 stayed the same and 1 stayed the same, and then we had the graph was above and below. So what we're going to look at now is look at when you put any function that you know, any graph that you know, if you put that on the bottom, 1 over f of x, what happens to that? So there's some patterns that we notice. We're going to go through our notes. The main idea is that your y value is changing to 1 over y. That's the main idea. And everything that you want to graph can be done just by changing your y value to 1 over y. But with that, there's some interesting things that happen. So here we have 1 over f of x. Here are some steps if you're asked to graph 1 over f of x and you know what f of x is. The first thing you're going to do is you're going to draw f of x. Sometimes f of x will be drawn for you. So sometimes step 1 will be done for you. On a separate graph, what's going to happen is we're going to draw vertical asymptotes wherever the original function has x-intercepts. So draw vertical asymptotes wherever the original function has x-intercepts. So let's say, as an example, we take one from grade 11 where you have 1 over x minus 3 squared. If you were drawing the bottom graph first, that's a parabola, and that parabola has been moved, how? To the right 3. So this is our original graph. Step 2 says on a separate graph, so draw a new set of axes, the very first thing that we're going to do is we're going to draw an asymptote at the non-permissible value at x equals 3. And this is very similar to what we saw in chapter 2. Wherever you have non-permissible values, you either have asymptotes or holes, but whenever you have a 1 over graph, it'll never cancel out, so it'll always be an asymptote. So we're going to start by drawing a vertical asymptote at your non-permissible value, and your non-permissible value will always be at x-intercepts of your original graph, because that's where the y value is 0, and you can't do 1 over 0. So again, it's based on this idea that you're just taking your y value and doing 1 over that. And if your y value is 0, then 1 over 0 is not allowed, so we're going to get a vertical asymptote. Step 3, we're going to draw horizontal asymptotes. So I'm going to go back to our example. Here, our original graph, our green graph, does get bigger and bigger and bigger and bigger. You have arrowheads showing that this parabola is going to infinity for its y values. As your y values get bigger and bigger, when you do 1 over that, you're going to get y equals 0. You can also use what we did in chapter 2. In chapter 2, we said, what's the highest power or highest degree of x that we have? In this, we would have an x squared on the bottom, right? So our highest power is x squared. We have no x squareds on the top, so you would have a horizontal asymptote at y equals 0. But that can also be seen by looking at your original graph. Anytime your original graph goes up forever, or if it would go down to negative infinity, then you're going to have an asymptote at y equals 0. So now we've got 2 sets of asymptotes for our graph. Step 4, it says specific ones. We're going to just We're going to just change step 4 to make it even simpler. Just plot some points. This one is talking about certain points that don't change, okay, invariant points. And that happens wherever the y coordinate is equal to 1 or negative 1. Those points won't change, but you don't have to be restricted to just that point. We're going to go back to our graph and plot some points. What are some points that you know on this green graph of x minus 3 squared? Does it make sense when I plug in 4 for x that I get 4, 1? When I plug in 5 for x, I get 5, 4. What you can do is take those y values and do the reciprocal. What would happen if I did the reciprocal of 4, 1? I would get 4, 1 over 1, which stays at 4, 1. What happens to the point 5, 4? I would get the point 5, 1 over 4. So all that's happening is our y coordinate is becoming 1 over that. So you could do some other points. You would get on this side 2, 1, 1, 1 over 4. So for step 4 here, just plot some points. Plot some points on your original graph, and then just take the y value and do 1 over y. And you can do that to as many points as you feel comfortable that you need to do. Usually we do one in each section, just like we did in chapter 2. And then finally, well, here's some other, step 4 and 5 are plotting some points. Some key points that we do are often places where you have a maximum or minimum. The graph that we chose, our minimum, happened to be our x-intercept, so we couldn't even graph that one if we wanted to. So steps 4 and 5, which is talking about plotting some points, you're going to plot a bunch of points. If you have key points like maximums or minimums, or if you know where the y values are equal to 1, those are good points to do. But it's not a necessity that you always have to do a maximum or a minimum like we have in this case, or a graph might not have them. Finally, once you've plotted a bunch of points, the last step is to draw your graph going towards the asymptotes. So here I've got a couple of points. I have asymptotes there already. So if it's not going to pass our asymptotes, our graph is going to look like this. In grade 11, sometimes we name different graphs by the shape that they look like. Do you remember what this one was called? A volcano. Because you've got your asymptote spewing lava out the top. Nice. So these are the steps that we're going to use for any graph. So now if we go to our examples, here's our first one. We have x squared minus 4, 1 over x squared minus 4. Now, I have set this up so that in your notes it shows each step one at a time. Okay? In reality, for each of these questions, what you would probably do is draw 2 graphs. Sometimes you draw them even on the same one, but this is what it would look like. First of all, you're going to graph what you see on the bottom, x squared minus 4. A parabola moved down 4. That's shown right here. Now, right beside it, I'm going to walk through those other steps and show you that you wouldn't draw each of these extra things one at a time. I've just done that to illustrate so that you can see one thing at a time when you're looking over this later. But the first thing you're going to do is you're going to look for, do I have any x-intercepts? Yes, I have x-intercepts at 2 and negative 2, so I'm going to draw my asymptotes. Then I'm going to look, does my graph go on forever? It does. So I'm going to have an asymptote at y equals 0, label these ones at x equals 2, and x equals negative 2. That's step 2 and step 3. For remembering how to do this, maybe you put those together and just say, start with my asymptotes. Once you've got your asymptotes, the next thing you're going to do is plot some points. Step 4 and 5 was about plotting some points. So look at some of your points on your original graph. You have 0, negative 4. That point is going to become 0, 1 over negative 4. All we do is take a y value and do 1 over the y value. What are some other points that you know? On our original graph, we have 1, 3. So I would know that I have 1, 1 over 3. Table of values comes in very handy. What happens if I plug in 3 into my original graph? Can you see that I would have 3, 5? So on this graph, I'm going to have 3, 1 over 5. Similarly, on this side, I have negative 3, 5. So I'm going to have negative 3, 1 over 5. So you're going to do as many points as you feel is necessary to get an idea in each section of the graph so that you can draw the asymptotic behavior. So now, in this part, I have a point in this part of my graph, draw it towards the asymptotes. A point in this part of my graph, draw it towards the asymptotes. Notice in this one, I didn't have a nice value where the y was equal to 1 or negative 1. So I didn't end up plotting that point. In my steps that I have here, I estimated where they would be, but that's not necessary. You can just use some nice points from your table of values. And if 1 and negative 1 don't show up nicely, then don't worry about it. Okay? If you are ever graphing the same ones on the same graph, it would be important to show that your graphs intersect at those points where it's not going to change. So wherever the y value is 1, that should be on both graphs. So this one, again, is another example from grade 11 because we have a parabola on the bottom. What did you call this one? Sad clown face? Nice. Here's our example 2, another parabola. 1 over x squared plus 1. Notice that our original graph, we're starting with our asymptotes. It has no x-intercepts. So you're not going to be able to draw any vertical asymptotes. There's no non-permissible values. The graph does go up forever, so there will be an asymptote at y equals 0. You have some points. You'd have 0, 1. That's going to become 0, 1 over 1, which doesn't change. If you plug in 1 into this graph, you get 1, 2. So now you're going to have 1, 1 over 2. If you want to plug in some more values, you could plug in 3. And you would get 10. So you're going to have 3, 1 over 10. The negative values are going to do exactly the same on the other side. So this graph is going to look like this. Another parabola that you saw from last year. What did we call this one? A speed bump. Nice. So now we can start looking at some of the graphs that we did for the first time this year. Here we've got a square root of x plus 4. This is your square root graph, moved 4 to the left. So once you've graphed your original graph, right beside it, you're going to start graphing the reciprocal. First of all, do we have any x-intercepts? Yes. 1, 2, 3, 4 at -4. You're going to get a vertical asymptote. Does the graph keep getting bigger and bigger? Yes, it does. Even though there's an arrow here that seems to be flattening out, it will keep getting higher and higher and higher. So you'll have an asymptote at y equals 0. Some points that you know, -3, 1. Well, when I do 1 over 1, that stays the same. That point won't change. If I do 0, 2, I'm going to get 0, 1 over 2. Can you tell me one more nice, easy point to figure out on the graph? On the original graph? Whole numbers? Close. 5. If you plug in our original graph, if you plug in 5, 5 plus 4 is 9. Square root of 9 is 3. That's another nice point to use. So we're going to have 5, 1 over 3. Now those first 2 points would have been enough to see what's going to happen, because you can now draw your asymptotic behavior. It's going to go down towards your asymptote here and up in this direction. Since we had nothing on the original graph when x was less than -4, you're going to have nothing on your reciprocal graph when x is -4. So the domain stays similar to what it was before. The only difference in domain between this black graph and our green one is in our green one you're not allowed to have x equals -4, because that would make you divide by 0. But other than that, they're the same. And the last example, and often they'll do this on the exam, is they'll give you a graph. So step 1 is done for you. We already know what the graph of f of x looks like. So right beside it, I'm going to graph the reciprocal. First thing I'm going to look for, is there any x-intercepts so I can draw my asymptotes? So for our x-intercepts, we have one here, we have one here, and we have one here. So at x equals -1, at x equals 2, and at x equals 5. Does our graph get bigger forever or smaller forever? Well, not on the left side. You see that it ends here. There's an endpoint. There's no arrowhead. But on the right side, there is an arrowhead that's pointing up. So we will have an asymptote at y equals 0. And then plot some points. -5, -1. It makes sense that that one's not going to change. So when you do 1 over -1, it'll stay -1. Same thing with -2, -1. That one's not going to change. All of these ones that are a straight line are going to stay a straight line. Yes?
Would you have a horizontal asymptote if it didn't go up forever?
No. If they had endpoints on both ends, there would be no horizontal asymptote. Now, here we have, well, let's do some more points. 0, 1, that one's not going to change. 6, 1 is not going to change. And 4, -1 is not going to change. Now here, I have to find out which way am I going to draw my graph. How do I know that it has to go down towards the asymptote and not up? Because we have seen some graphs sometimes cross those horizontal asymptotes. Well, if you're wondering, you could take a different point it looks like here at negative 1.5, I have negative 0.5. Now I'm going to change this negative 0.5 to negative 1/2. What's the reciprocal of negative 1/2? Negative 2, which would show up as going down. You could do the same thing with a couple of points in here. Those two green points are where the y value is 1/2. They're going to be at 2. So this part of our graph goes up towards the asymptotes. Same thing here. This part of our graph will go down towards the asymptote. This part of our graph goes up here, and since there is an arrowhead, we'll go down towards the asymptote there.